Hello guys, welcome to our new video tutorial on big data. So in order to understand the big data, first coming to the definition, what actually the big data? What makes data a big data? So a big data by definition, there's actually no standard definition for the big data. So here we have taken a simple language to understand the big data. It simply is a data whose scale, diversity, complexity require new architecture, techniques, algorithm, and analytics to manage it. And extract value and hidden knowledge from it. Simply means we have a lot of data. We want to extract some of the valuable information from that data to get information which is required to be any business or something else. So that is something called knowledge discovery from that raw data. We have a huge amount of big data, but we require some of the information which hidden inside the data. In order to get that data, we will mine the data from that huge amount of data from, and that huge data is of complex scale and lot of diversity. So that is the simple definition of that big data. So what actually the characteristics of the big data? First is scale. A big data has a use volume use. It is of zettabyte of data, terabyte, petabyte, zettabyte of data. As the data is increasing exponentially in current scenario, so we required a big data analytics to understand what actually information is hiding in that data. You can see the data volume is increasing 44 times from 2009 to and estimated as 44 times to the 2020s. That is equivalent to 35 zettabyte, which is was earlier in 2009 is zero point 0.8 zettabyte. So you know the units of the data: GB, then terabytes, petabytes, exabytes, zettabytes, tweeters per day. Data is increasing exponentially. In order to get the sentiment analysis, what is actually people are discussing about your, for example, discussing about your company, you need to get to know what share price is affected by the sentiment is tweeted by the people. So in order to get the sentiment, you need to have big data information. It was unstructured data, so you need to get positive, or you need to find the information hidden in that particular tweets, what people are tweeting about your company. Now coming to the second characteristics, the complexity, also called a variety. Actually, the data is a various format and structure: text, numerical, image, audio, video, sequence, time series, social media data, multi-dimensional data. So these all data have different format. In order to get the data from these of the different format, you need to have perform some operation standardization to do a mining operation on it. So a big data's second major characteristic is the complexity. It can handle all of any structures of the data. You don't have to use simple array type of data. You can handle all various type of structure in that data format. A single application also can create a creating a many type of data. So example of Facebook, YouTube, Twitter is generating some of unstructured data. um, your retailer shop is generating structured data in the form of array and many other forms of data. The third is, and to extract that knowledge, all these stuff data need to be linked together in order to in a logical format. We'll discuss in more detail when we go into a Hadoop tutorial in us to understood how we'll approach big data operationalization and the implementations. And third, the major characteristics of the data is speed, also called velocity. Data is being generated fast and need to be processed fast. Online data analytics, late decision, missing opportunity. In the current scenario, data is generating at a huge rate, and we need to analyze it before any competitor would take advantage of it. So we need to be very fast in order to get to discover that knowledge from that big data. So example like e-promotion, based on a current location of purchase, you can like send promotion right now, store next to you. So This way you can creating you are generating more sales, and by losing this one of the opportunity, you can lose your sales out by another competitors. Healthcare monitoring is another example. Sensor monitoring of your activities and bodies. Any abnormal require measurements require immediate actions. So this can be handled by big data. Big data in three V's, as it explains why this big data is growing in a lot of transaction, interaction, observation. You can see here the ERP system is having a huge megabyte of data, and because the customer relationship management is going to the gigabyte, and the wave analytics contain a terabyte. Now the big data is petabyte, more than petabyte, zettabyte of data. Even the one of the extension form of big data is 4V, as I explained the 3V's, that is volume, velocity, and variety. But one is the veracity. Veracity is one more of the form that data in the doubt, uncertainty due to the data inconsistency, incompleteness, ambiguity, latency, deception, model approximation. So uh, in order to get this thing we do, you will create your mathematical model and prediction. On the basis of that prediction, these inconsistency in data will be filled by that models. Now harnessing a big data, a data as you know aware about the OLTP OLAP system. OLTP is online transaction processing system. OLAP is online analytical processing system. In OLTP is what there is different operation database for every department. You need to you need will take that data in structure form and will create your own data warehouse, and where you will normalize your data in one of the layer. Data warehouse is of simply a 3-tier structure or 4-tier structure, depend on your requirement. So all the data should be collected on the stage layer. Will be taken out from various different department. That finance department had different data, marketing department had different data, HR department had different data. So these are data stored in their different data marts. So we'll collect these different all data from these three four sources and collect it to the core layer. Then we'll define link among all the three data and process to our next level, and that is core layer. Then according to our business requirement, we will further proceed in our just that called semantic layer for our business requirement. So now let's discuss real-time analytics processing, RTAP, just like text analytics of Twitter and social marketing data. Who generating the big data? Facebook, Twitter, WordPress, YouTube, Flickr, social media network. A lot of websites are generating a lot of data. Even the scientific instrument collecting all sort of data. The astronaut not are very dependent on this type of data. And the mobile devices, also sensor technology, networks. The progress and innovation is no longer hindered by the ability to collect the data, but by the ability to manage, analyze, summarize, visualize, and discover knowledge from the collected data in a timely manner and in a scalable fashion. The model has changed now. The models generating consuming data has been changed. Old model, the few companies generating data, all other are consuming data. Now all of us generating data and all of us consuming data. So world is not changed. All of future is the data only. Who's driving the big data? Mostly the business, the complexity and the business value. You can see here the business value. First, the business intelligence part. Business intelligence is the yes, you can do not use your mathematical model. You simply have a lot of used data and just you do slicing and dices and doing filter and your logic, business logic on that, and you need to find out intelligence of, into the data. For example, we have a used data of bank. Now we will want to find out whose are the customer, those residing outside the domestic country are paying tax to that particular country. So this is something we need to mine our data own data, and we did not require any prediction or mathematical model in it. So it is just intelligence part of from the data. This is called business intelligence. But something is different: predictive analysis and data mining. Predictive analysis is just like you need to predict on the basis of data and mining of the data. For example, you have a lot of bank data. You just want to know whose are the actual consumer who default risk is high. So in order to create more efficient plan for your loan, you need to check, you need to verify that predictive model on the basis of what you have actual data in your historical trend. You can define which are the suitable customer to be approved for loan, or which are not to be approved for loan. This is considered the predictive analytics. This is much or high level. So ad hoc querying and reporting, data mining techniques, structured data, typical sources, and small mid side. So intelligence, business intelligence, just we put all the ad hoc querying, reporting, mining techniques, and structured data, typical source, small to mid size of data set. But in the predictive data analytics, we have optimization and predictive analytics, complex statistical analysis, all type of data and many source, very large data sets, and more of real time. Value of big data analytics. Big data is more real time in nature than traditional data warehouse application. Traditional data warehouse architecture, Exadata Terra, not well suited for the big data application. These are for, you can say, GB of data. You cannot move ahead from the gigabyte of data. As the complicated things, you cannot, if you query some of the query on that type of data, it will take more than a year to get the particular result. So these are the old traditional data warehouse architecture, but now it's changed. CS nothing, massively parallel processing, scale out architecture are well suited for the big data apps. You can see now the big data warehouse is an appliance system between time and value. Challenging in handling the data. Now actually the complexity in data is increasing day by day, so a lot of challenges also increasing daily. So in order to handle that, we require new architecture, new algorithm, and new technology to handle that complexity. Also in a technical skills, expert in using new technology and dealing with their data. So major big data challenge is lack of software and technology, lack of analytical, insufficient budget, and already using. Now, what technology do we have for the big data? We have lot of technology in order to do a big data. These are some of the technologies: are vertical apps, ad media apps, log data apps, data as a service, business intelligence tools like Oracle, Hyper, SAP, Cognos, is IBM reporting tools, good data, B-time, QlikView is one of the and data visualization tools, analytic and visualizations, SaaS, TIPCO, lot of software available, and the operation infrastructure is the is the major player in that. You can also call the Informatica also one of the major player. Now in terms of technology, the Hadoop is the major technology in the big data. So these are the technologies: big data technology, Hadoop, Vertica, MapReduce, KDB, Nextchart, Teradata, ETL tool, extract. ETL is extracting, transforming, and loading things. Fast data analytics, MATLAB, Hadoop, SAS, Deep Insight, BPO, BI, and a lot of business intelligence tools. What now? We already learn about what actually is big data. Now, what will be the outcome of this code? We will learn all the platform design for to be work, learn about the Hadoop and their different languages, learn advanced analytics tool on the top of Hadoop, and statistical tool to managing big data, and learn art of technology from recent research paper. Also, uh, along with that, you will learn all the different type of algorithm which is required necessary in all type of big data and managing all complexity of the data. Thank you. Hope you subscribe our channel for your new upcoming video. Thank you. Bye.